Well, good day, everybody, and let us continue in our discussion of solutions. And finally, let's get into some quantitative stuff. So let's start right away with this consider. Consider dissolving 34.75 grams of sodium chloride in enough water to make 652 milliliters of solution. What is the concentration in M? Concentration in M. Ooh, I think we need some notes. Yes, that is correct. Let me change pen color so you can read my notes. And that's difficult enough as when I have a bright color, isn't it? Okay, so we started talking about solutions. We talked about a definition. We talked about components, right? And we said components are solute and solvent. And we talked about a process, and we call that process solvation. And we said, hey, you have to overcome the intermolecular forces or the forces of attraction in the solute, and you have to overcome the forces of attraction in the solvent. And then the solvent particles are attracted to the solute, and they surround the solute. Good. And then we did what? We characterized the types of solutions, and we said we can have a saturated solution and a unsaturated solution and a supersaturated solution. And then we characterize the types of solutes, right? We said I could have an electrolyte or a non-electrolyte, and under the electrolytes I could have strong electrolytes and weak electrolytes, right? And non-electrolytes don't dissociate when they dissolve, and electrolytes do dissociate when they dissolve. Good. Now, and we talked about factors affecting solubility, right? Solubility being essentially how much of a substance, how much of a solute will dissolve before a saturated solution is formed, and what factors affect that. And we said, hey, the IM forces of the solute and solvent are important, and we said, hey, likes dissolve likes. We said that temperature is a factor, that when I raise temperature, solids and liquids in water tend to increase their solubility, but when I raise temperature, gas in water tends to decrease its solubility. And then pressure. And pressure has very little effect on solids and liquids, but as I increase pressure over the gas, there is more solubility. The gas dissolves at a greater level. Good. So that's kind of where we are. And now we want to quantify amount of solute in the solvent. Okay, we want to quantify that. And to do that, we're going to use a term called concentration. Concentration. And concentration really is just what I said up there. It is a measure of amount of solute dissolved in the solvent. Now, there are a number of measures of concentration. We could use parts per million. We can use mole fraction. We can use molarity. And we really don't care about any of those. Those you'll learn about in AP Chem, maybe. The big one that we want to learn about is molarity. Right. Yeah, molarity. No, molarity. And the symbol is a big M. And so let us write our expression for molarity. Molarity is equal to moles of solute per liter of solution. Good. And this is important that we understand this entire definition. Some people will say, oh, it's moles per liter. Well, that's not quite right. It's not moles of anything. It's only the moles of solute. And it's not liters of anything. It's liters of solution. What does that mean, liters of solution? Well, that means that is the liters of solute plus the liters of solution. Now, normally, liters of solvent. Normally, our liters of solute is small, but not always. And then sometimes, when I add my solute to the solvent, the volume actually decreases instead of increases. And so we have to figure out the liters of total solution, and that's what we use in our denominator. Got it? Okay, here we go. Well, let's try a problem. All right, I have 34.75 grams of sodium chloride, and I have enough, notice how they state this. We have enough water to make how much? 652 liters of solution. All right, they tell us how much stuff of solution I have, how much volume. Okay, we want molarity. Molarity is moles of sodium chloride because that's my solvent over liters of solution. Good. What are my liters of solution? Well, my liters of solution, they tell me I have what? Excuse me. They say I have 652 milliliters, but that's not liters of solution. How do I get liters? Well, it's 1 liter per 1,000 milliliters, right? Let's get rid of that. There we go. Give us some more space. And so I'd have 0.652 liters of solution. Now, how do I get moles of sodium chloride? Well, my moles of sodium chloride are equal to, yoink, I'm out, 34.75. Woohoo! 34.75 grams of sodium chloride times what? Well, I have 1 mole of sodium chloride per, oops, what do I need? I need my periodic table. Woo, okay, where is sodium? Sodium, 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 sodium. Looks like 22.99, 22.99, 22.99, yoink, oops, wrong place, 22.99, 22.99 plus chloride. Where's my chloride? 35.45 plus 35.45 grams. Get up my handy dandy TI-30XA. And what do I have? 34.75 divided by quantity, 22.99 plus 35.45. And I get 0.59462 moles of sodium chloride. Cool. Excellent. Right? I have 4 sig figs. That means I have 4 here. I'm going to carry the 2 and round it at the very end. So what's my molarity? Well, my moles of solute, 0.59462 moles of sodium chloride over, what are my liters of solution? Zoink, 0.652 liters. And what's my answer? Okay, divided by 0.652. Woohoo! How about 0.912 big M? And how do we say that? We say that as a 0.912 molar solution of NaCl. That's it. Hey, piece of cake. You guys can do that? Yes, you can. You guys give this one a shot. Bring me back when you're ready. Well, we're going to dissolve 97.3 grams of silver nitrate in enough water to make a solution of 483.5 milliliters. So liters of my solution are going to be equal to 843.5 milliliters times 1 liter per 1,000 milliliters, and I get 0.8435 liters of my solution. Now I need moles of my solute, moles of my silver nitrate, and that's equal to 97.3 grams times 1 mole per, well, what is silver? Silver is 107.87. 107.87 plus nitrogen is 14.01, right? I don't remember that. Plus 3 times 16.00 grams. Yoink. Let's do some calculating. 107.87 plus 14.01 plus 3 times 16, I know it's 48. 48 equals, it's like 169.88 inverse times 97.3, and I get 0.5727 moles of silver nitrate, right? And remember, why do I draw those lines under there? Because I want to carry an extra digit that's not significant, and then I round it at the very end to the significant figures. Here I have 3 sigs, so that means I only have 3 sigs in my answers, but I don't want to round this yet, or else it'll throw off my answer. Just a reminder why I put that number, put those lines into the number. So the molarity is what? Moles per liter. So 0.5727, not just any kind of moles, but moles of my solute over not just any liters, but liters of my solution, 0.8435 liters. Woohoo! Divide that by 0.8435, and I get 0.679 big M. And I would say that is what? I have a 0.679 molar solution of silver nitrate. There we go. That was a piece of cake. Speaking of piece of cake, how about pancakes? So it's the morning, and a piece of pancake would be good with some butter. Yeah, and some maybe Mrs. Buttersworth on top of that. Well, we better go on and work before I get too much hungrier. More hungrier. Good English. Yes. Okay, here we go. Consider a 0.175 molar solution of silver nitrate. Okay. How many grams of silver nitrate are required to make 197 milliliters of that solution? All right. Okay, I'll do this one for you, and then you guys can do the next one by yourself. Here's how we work it out. I have molarity, right? I know molarity is equal to moles of my solute. What's my solute? Silver nitrate. Moles of AgNO3 over what? Liter of solution. Okay, so I know that definition. What is given? I'm given molarity, and it says to make how many grams of silver nitrate are required to make 197 milliliters of solution. So they give me the liters of solution. So what do I have? What do I need to do? I need to solve for moles of silver nitrate. So moles of my solute equal liters of solution times molarity. So that's another way to use this concept. All right, what are my liters of solution? Well, I have 197 milliliters times what? 1 liter per 1,000 milliliters, right? So that gives me liters of solution. What's my molarity? How about 0.175 molar? Cool. And what do I get out of that? 197 divided by 1,000 times 0.175, and I get 0.03447 what? Moles, right? Moles of my silver nitrate. But that's not the answer. They want grams of silver nitrate. So grams of silver nitrate equal 0.03447 moles of silver nitrate times, well, what is it? 107 point what? 87 plus 14.01 plus 3 times 16.00 grams per 1 mole of silver nitrate. Right? All right, let's run the numbers. 0.03447 times quantity 107.87 plus 14.01 plus 3 times 16 is 48 equals 169.88. I remember that. And I get 5.856. So how many sig figs can I get out of this? 3. 5.86 grams. Woohoo! 5.86 grams of silver nitrate. All right, you guys do this one. Well, once again, same kind of idea. I have, what am I seeking? I'm seeking grams of iron 3 nitrate. I'm given so much solution and molarity. I know that molarity equals the moles of my iron 3 nitrate over liters of solution. I'm given this, I'm given this. I can solve for moles. Once I get moles, I can get grams, right? Yes. So here we go. Moles of iron 3 nitrate equal to molarity, 0.250 molar iron 3 nitrate times liters of solution. What do they give me? Well, once again, they don't give me liters. They give me milliliters of solution. So I have to convert those milliliters to liters. So that is 1 liter per 1,000 milliliters. Okay, so how many moles of iron 3 nitrate do I have? 0.250 times 157 divided by 1,000. And it looks like I have 0.03925 moles of iron, iron 3 nitrate. Let's check that calculation again. 0.25 times 157 times divided by 1,000, right? It looks good to me. All right, so then we have to get grams of iron 3 nitrate, which will equal my moles, 0.03925 moles of iron 3 nitrate, times, oops, we're going to have a big molar mass this time, aren't we? Times, okay, what is iron? What is iron? Iron, iron, iron. 55.85, cool. Okay, so 55.85 plus 3 times 14.01 plus 3 times 3 is 9. 9 times 16.00, right? And this is grams per 1 mole. And then my moles will cancel and I'm left with grams, right? Here we go. Okay, let's try to get this right. I have 55.85 plus, I have 3 nitrogens there, right? 3 times 14.01, good, plus, and I have 3 times 3 means I have 9 times 16. Looks like I have 241.88 times 0.03925, and I get 9.493, 9.49 grams of iron 3 nitrate. Let's check those calculations again. Okay, so wee-hee, that's exactly what I got. All right, any questions? Excellent. Okay, let us move on. All right. I look at this and it says I have 0.250 molar solution of iron 3 nitrate, but it doesn't tell me anything about grams or moles or liters of solution. What am I missing here? Well, what's the question? What is the concentration of nitrate ions? Aha! In the solution. Okay. Well, this just has to do with what does this really mean? If I have 0.250 molar iron 3 nitrate, what happens? What does that mean I have actually in solution, right? Well, here's the issue. What is iron 3 nitrate? Well, it is a metal plus a nonmetal, right? A polyatomic here, correct? So that means this is ionic. Good. Now, What happens to ionic solids when they go into solution? Well, ionic solids, we said last time, or the time before that, are strong electrolytes. Electrolytes. And what do strong electrolytes do? They break into ions. So they break into their ions. So what happens when iron 3 nitrate goes into water? Okay, so there's the solid, and then it's going to go into its aqueous species, right? So what happens? Well, it's going to break into its ions. It's going to break into iron 3, and it's going to break into nitrate. But how many nitrates? Well, I have 3 nitrates uh, for every one iron 3 nitrate. So it's going to go like that. Good. And this is going to represent also moles. So if I have 1 mole of this, I will have, when it dissolves, 1 mole of this and 3 moles of this. Well, what if it's 1 mole per liter? Well, that means I would have 1 molar this. This would be 1 mole per liter. And this would be 3 moles per liter. So this would be 1 molar. And what about this? This would be 3 molar. So what we've just shown here, that when I have an ionic compound and it dissolves, the coefficients in that equation not only represent moles, but they also represent the concentration in terms of molarity. So if I have 0.25 molar, I have 0.250 molar iron 3 nitrate times, and I want to know what's the concentration of my nitrate. I have what? 3 nitrates per every 1 iron 3 nitrate. Then what's the molarity of my nitrate? 3 times 0.25 would be 0.750 molar nitrate. Hey, that's not hard at all. We don't even have to really write notes, do we? Okay, you guys do this last one. Well, I have sodium carbonate, so we need to know what that formula is. Sodium is a +1, carbonate is a -2. So what's my least common multiple? 2. 1 carbonate, how many sodiums do I need? 2. So it's Na2CO3. When that dissolves, notice it is a metal and a non-metal, or a metal and a polyatomic, so this is ionic. That means it's going to dissociate completely. It's going to be a strong electrolyte, meaning I'll have sodium and I'll have carbonate in solution. How many sodiums do I have? Well, I have 2. Good. And if I start off with 0.125 molar sodium carbonate times what? And what are we looking for? Sodium ions. So I have 2 sodium ions per every 1, right? Sodium carbonate. Then I'm going to take 2 times 0.125, and I get 0.250 molar sodium solution. Cool. And what would it be in terms of carbonate? Well, I have 1 carbonate to 1, so it would be 0.125 molar carbonate. Got it? Hey, piece of cake. Well, that is about it for today. Next time, we're going to jump into the yellow screen, and we're going to talk about solution stoichiometry. So, until then, be good.